Good morning everyone. Today we will discuss our computer structure and architecture. So before entering to this subject, I would like to discuss few fundamental things regarding computer. So myself, Amod Kumar Bagh, lecturer in computer science and engineering department. So guys, all of you might have known, you might have seen what is computer, how computer looks like, and all, right? So what is computer? Anybody? Okay, I will not take much more time from you. So please have patience and listen carefully. Please give your mind attention to it. Okay. Fine. So what is computer? Computer is an electronic, high-speed electronic device which takes input from the user, it stores the data, it processes the data and gives the output. Okay. But I repeat, computer is an high-speed electronic device which takes input from the user, it stores the data, it processes the data and gives the output. So, learning regarding computer architecture, first we will discuss few things about all these things. You know, the basic structure of a computer system. The basic structure of a computer system is defined in such a way that it is divided into mainly two parts. So let me discuss first, then I will explain a little bit more. So basically computer has been divided into mainly two parts. One is hardware part, another one is your software part. Hardware part and software part. What is hardware parts? What is software parts? So let me tell you, all the physical components of the computer, that means to which we can see, we can touch, we can feel, all the physical components of the computer is called as your hardware. Hardware components, hardware parts. And what is software parts? This is the programming parts or the logical components of the computer to which we cannot see, we cannot touch, we cannot feel, but we can get the service. Okay? Internally, how it's processed? Internally, it works in such a way that we can be able to use the hardware for our purpose. So mainly it's divided into two parts, that is hardware part and software parts. Again, we'll come to your software. That is also divided into again two types. What is those? System software and application software. What is system software? You know, when you purchase a new computer or new desktop device, it is, I can say, completely a dead person like that. It will not function, it will not do anything, it will not give you service, it will not provide you to use the computer because it is in the beginning it is empty without operating system. So without operating system is nothing but the system software. So the definition of operating system is it is a system software which acts as an interface between the user of the computer and the hardware. Okay. So guys, what is system software? This is a software which is used to run a particular system or a computer. That is called system software. Example, operating system. In mobile device you might have seen, you know, everyone is having mobile. So all are using Android. Android is having also different versions like Android 8, 9, 10, 11, 12, 13, 14 like that. Android Junior Bagh, Android Lollipop. So many versions of Android apps also there in the market. Similarly, in computer we are using Windows as an operating system, Linux as an operating system. Linux, Ubuntu, All these are the part of Linux operating system. DOS, disk operating system. Vista, Windows Vista is the version of Windows 2007, 8, 2009, 2010, 2011, 2012. These are the various versions of Windows operating system. So, if we not install operating system in a computer, we cannot use that computer for our task, do our task. We cannot use that because all the hardware will remain dead. Give life to the hardware, we use operating system. Under operating system, we have to use various application software. So under system software, we can use application software. What is application software? These are the various softwares we used to have to do various purposes, to do various tasks. For example, if we want to watch any photo, videography, want to listen any songs, want to do our office automation task. For that we use Microsoft Office, Excel, PowerPoint and all these things. For hearing songs, we use media player or MP3 player. To watch video, we used to install video player like VLC, Windows Media Player, KM Player. These are the application software. To do calculation, we use calculators. So calculator is an application software. This all application software runs under your operating system. So this is all about your software. Then hardware, as I said before, this is the physical components of the computer to which we can see, we can touch, we can feel. For example, the monitor of the computer, the mouse we are clicking, the keyboard we are pressing, these are the input device, but we can touch, we can feel, and monitor is the output device. We are getting the output. The hard disk, memory device where we can store our data. These all are your hardware. So basic structure of a computer system is consist of like functional units, basic operational concepts, is performance, instructions, language of the computer, operations, operands, instruction representation, logical operations, decision making, MIPS, multi instructions per second, addressing. These are the basic structure of a computer system consists of. So the functional units we'll see for the first point we can discuss the functional units of the computer. Okay, so I'll keep 1 minute here. Computer is a high-speed electronic device, I said. Yeah, but one more point. This is a binary device. Binary device means it can understand only 0 and 1. Other than 0 and 1, computer cannot understand anything. Whatever input we are giving to the computer, first it will try to understand by its own language, that is binary language. It will convert our input data to binary numbers. Then it will process and again it will give the output, not in binary form but the user level form. But user can understand. Suppose if we want to see one photo, it's giving 0, 1, 1, 0, 0, something multiple, some binary digits are coming. How can we identify which thing is this? So for that, it will convert the output data. First, it will convert to user understandable language. Then it will present in the output screen. So we can know, yeah, this is the photo. So now see functional units. A computer consists of 5 functionally independent main parts. Those are input, memory, arithmetic and logic unit, output unit and control unit. I repeat, computer in functional unit of computer, you can see 5 things. It consists of taking 5 things, functionally independent main parts. Those are input, memory, ALU, arithmetic and logical unit. Next is output unit and control unit. Control unit, input unit, memory unit, arithmetic and logical unit, output unit, then control unit. So simply I will tell you, input unit, this is the input part, this is the unit by which we can give input to the computer. Correct? Input unit is the unit of the functional units of a computer through which we can give input to the computer. Right? So input unit, the source program, high level language program, coded information, simply data is fed to a computer through input device. So input devices are like keyboard, mouse, joystick. These are the input device. Through input device we can give the input. Whenever a key is pressed, one corresponding word or number is translated into its equivalent binary code. As I said, binary code over a cable or fed either to memory or processor. Example: joysticks, trackballs, mouse, scanners, keyboard. These are the input devices. The control unit, suppose central processing unit, CPU. We are saying CPU. This is the control unit. In CPU, input unit, output unit, memory unit, arithmetic and logic unit, control unit, all are combining into one place. That is called central processing unit. Okay. CPU is also called processor, the active part of the computer which contains the data path and control units, and which adds numbers, test numbers, signals, input output devices to active and so on. Right. So what is ALU? Arithmetic and logic unit. It performs the arithmetic operations in arithmetic ALU. In arithmetic and logical unit, we can perform arithmetic operations. It is also called as brain of the processor. Okay. The entire operation can be done with the help of registers. Registers are used to store temporary data for their operations. Okay. Registers are faster than memory. Registers can hold variables and intermediate results. Memory traffic is reduced, so program runs faster. For example, suppose you are using calculator. One number is 3, another number is suppose 4. So if you want to do addition operation, that means 3 plus 4 equal to, how much time it is taking to give 7 as an output? Within fraction of second. 3 plus 4 equal to, suppose pressing equal to 7 as your output. So in computer what happens? In ALU, registers are used. This is the very fast memory and temporary memory, where suppose x is a variable, y is another variable. Suppose x is the first variable, y is the second variable. So and x plus y equal to, suppose z is another variable which will hold the output of these two variables data. That means x is equal to 3, y equal to 4, and z value will be 7. Instantly it will store. So for that we are taking 3 registers. One register or one register also is okay. In one register, suppose first value x, second value y, and the output value is z. 3 plus 4 equal to 7. We are getting instant. Next is control unit. It is also called as a brain of the processor. Who is the brain of the processor? Control unit. It fetches and analyzes the instruction one by one and issue control signals to all other units to perform various operations. Got it? For a given instruction, the exact set of operations required is indicated by the control signals. The result of instructions are stored in memory. The component of the processor that commands the data path, memory, and input-output device according to the instruction of the program. Okay, next is memory unit. I said memory unit is the unit where we can store our data. Whatever the data computer used to give as output, that also used to be stored in one place, that is called memory. Memory is nothing but a storage device. It stores the program and data. It is divided into n number of cells. Each cell is capable of storing 1 bit information at a time. Got it? I repeat. Memory is nothing but a device. It stores the program and data. It is divided into n number of cells and each cell is capable of storing 1 bit information at a time. There are two classes of memory. One is in computer system. You will find two types of memory. One is primary memory, another one is secondary memory. What is primary memory? What is secondary memory? Let's discuss primary memory. It is made up of semiconductor materials, so it is called semiconductor memory. Primary. It is made up of semiconductor materials, so it is called semiconductor memory. Data storage capacity is less than secondary memory. Secondary memory, you know, pen drive, your chip, memory chip, pen drive, hard disk, your SSD. These are the secondary memory. Cost is too expensive than secondary memory. Secondary memory, suppose 1 GB you are getting in, suppose 1000. Primary memory is much more higher than that. You may get in 3000 or 4000 or 5000. Like it depends upon the company and the capacity and the features that you are purchasing. CPU can access data directly from where? From primary memory, because it is an internal memory. So internal memory is nothing but the primary memory. CPU can access data directly from the primary memory. So data accessing speed is very fast than secondary memory. For example, RAM and ROM. RAM means random access memory. ROM means read-only memory. So RAM and ROM, we will see few difference. Random access memory, RAM. Read-only memory is ROM. So RAM is volatile memory. ROM is non-volatile. What does it mean? When data loss will happen when power turns off and the data is used to hold data and program while they are running. When power will be lost, power will be off, the data remain in the RAM will be erased. That's why that is called volatile memory. Okay. And ROM, it retains data even in the absence of power source, and that is stored program between runs. Even after power turns off, the data present in the ROM will remain same. It will not be deleted. That's why that is called non-volatile memory. And RAM is temporary storage medium. ROM is permanent storage medium. Until unless it will not delete, it will not be deleted. Okay. User perform both read and write operation in RAM. User can perform only read operation, but in ROM, read only. Okay, that's the difference. And RAM also divided again into two types: SRAM and DRAM. In SRAM, no refreshing is needed. In DRAM, dynamic RAM, refreshing is needed. Information is stored in one bit cell called flip-flop in static RAM. In dynamic RAM or in DRAM, information is represented as charge across a capacitor. Okay? And SRAM, more complex hardware, but in DRAM, less complex hardware. SRAM is more expensive than DRAM. The access time in SRAM is 10 nanosecond. The access time is in DRAM is 50 nanosecond. Okay. Again coming to cache memory. This is also one temporary memory. A small and very fast memory that acts as a buffer for a slower large memory. We will discuss our cache memory in detail in another chapter. Now we will discuss about secondary memory. Secondary memory or non-volatile storage is a form of storage that retains data even in the absence of power source, and that is used to store the programs between runs. Okay, it is made up of magnetic materials, so it is called magnetic memory. Data storage capacity is high than primary memory, but it cost is too low than primary memory. CPU cannot access data directly because it is an external memory. That's why only we are using primary memory, because while executing a program or executing a data to get the output, the processor will access the data from the primary memory, because that is the faster device which use registers. So registers are the temporary memory, but it acts faster than normal memory. The example of secondary devices: magnetic disk, hard disk, CD, DVD, floppy disk, etc. We will discuss later thoroughly. We will come to our output unit. A mechanism that conveys the result of a computation to a user, such as display or to another computer. That means in output unit we will get the output. Whatever we are giving the input, it will process. Then finally we will get some result, right? We have to get the result. That result of that output will be displayed in the output unit. We are using LCD, liquid crystal display, LED, light emitting diode, like that, so many things. It supports RGB, red, green, blue color. Associated with each dot on the display determines the intensity of the three colors components in the final image. Okay. We will discuss the basic operational concept in the next class. So we have discussed today the functional units of a computer. Thank you.